Hi guys, this is our online lecture 2, calculus 2. Alright, and then we are going to solve 5 questions today. Alright, we means you and I. For me, I provide you guys the hints, and you guys going to give answer for each of this and post it so on blackboard. So listen carefully. So what's the hints? So I'm going to convey here. Alright, so shall we start? Okay, let's start. Okay, so question 51. Right, so firstly record this very fundamental result, namely differentiate ln x respect to x, we will get 1 over x as a result. Okay, so now we are going to reverse back this process. In other words, means that we are going to use the integration. Alright, so then you see we are going to have a next result. See familiar? How familiar with the question 51? But you may feel surprised. I would write down ln x, but instead modulus x. Then plus c. Yeah, because so this result here, the limits are not given. The limit refers to the lower limit and upper limit are not given. Right, that's why that plus c is necessary. Okay, back to the, so just I say that you will feel surprised on the why I'm not using the ln x, instead using ln modulus x. Reason is quite simple, just because of the ln, alright, the ln x itself only defined for x positive. Can you recall? Therefore, to avoid the ln x to be undefined, modulus is always necessary. Yeah, so these are only hints, so you need to know, so in order to solve the question 51. Right, and then now you can start to solve it, and then enter your answer in a piece of paper or, okay, so whatever. Right, so then now we ready to go for next question. In the next question, question 55. Okay, you will see this question is getting a little bit complicated, just a little bit complicated, not very complicated. So having the sine t now on top, and then the 2 minus cosine t as the denominator, then with respect to t. Okay, let's look at this this expression. So expressions of integrands, so of integral sine t over 2 minus cosine t. Can you spot any connection or relationship between the numerator and denominator? You may find that when we differentiate the 2 minus cos t, it just accidentally you will get sine t. Alright, in other words, means that we differentiate denominator, we are going to get the numerator. So with this so the phenomenon, so we have the second very powerful and versatile result in integration regarding the natural logarithm function. This is the one. Integrate f prime x divided fx dx. The result is ln modulus fx plus c. Right, so can you match with the question 55? So just now there's so I brief you. Alright, so looks very familiar, right? Alright, so so the question 55 is considered done on my part. On your part, you need to provide the solution, you need to provide the answer for submission. Alright, next we go to question 59. expressions here. Do you have the make sense? Alright, so look carefully here. How's the integrand about? Remember, differentiate ln x, we get 1 over x. So, and again here by chance, you see 1 over x is around. So that means that, in order to get the 1 over x, we are going to differentiate the ln x. And it also happened that the ln x also the part of the integrand. Then what does it mean? So that means that we are going to use the method of substitution we learned in the MAT 132. So let u equal to ln x. Okay. Alright. And then here is the recall what you learned is the last semester, the last chapter. So that means the next step we're going to do is we're going to get the du dx, right? Right. So then du dx is equal to 1 over x. The principles of the method of substitution integration is that, so we are going to replace all the expression in terms of x and also dx in terms of the du. Okay, now we go for the first step to replace so that the dx in terms of the du as follows. Okay, dx equal to x multiply du. Okay, yeah, with this, so we have the question 59 in its new log as, right, the limit we haven't changed yet, that means it's still x, so from 2 to 4. Yeah, this one I put the x because I didn't change the limit yet. I just changed everything, the integrand and the differential. Then I'm going to have 1 over u squared du. Simple enough, right? Alright, if you still cannot see this, how you're going to solve it, so that then I can put it another way for you, for your guys also to see again the question 59. Again like this, then you can write down here u power negative 2 du. Can you solve now? Using the power rule for integration, you can solve it easily. So that respect to u. And don't forget that in here, so that after you solve in terms of u, you have to convert back in terms of x. So to get the final answer. Any questions? Okay, so or else we go for the second last question. Okay, question 63. Alright, so you see the rather simple in the structure there. So it appears y is just a single item tangent. Anyone feel phobia about trigonometry? No need to feel phobia. It's just like this. So you and me, it's just a normal thing, a normal person. Okay, tangent. Alright, so in here I will just give one clue for you here. We are going to use this result again. Alright, squeeze a little bit here so that everything also can fit in nicely. Alright, ln, remember modulus is unnecessary. Okay, no place to write the c here, so forgive me, I put down the c on top here plus c. Okay. Alright, so we are going to use this result. So, but you find that here tangent is it's just equal to tangent over 1, right? So you find that here we can use this with the tangent by itself, but instead using the sine over cosine. So rewrite the tangent x over 2 equal to, so again here I squeeze the right thing in here, over cosine x over 2. Alright, so can you see here, so that means that so for the security purpose here, so we just doing one simple substitution before this. So before that, so we use as the result, so the before. Alright, before means so using the integration f prime x over fx dx equal to ln modulus fx plus c. Alright, in order to synchronize, so our result become this. Everything now says so du. Then only then we can also write the modulus fu, then the plus c. Okay, so then this question also considered done. Alright, and the last question is the most interesting one. Should I say that every so calculus 2 students have to know this? Alright, see the expression or the question first. Yeah, this is indefinite integral without the limit given. Therefore, the final answer must have the plus c. And inside here, so quite ugly thing here, ln, then modulus secant x plus tangent x, then whole thing dx. Looks scary, right? Alright, so but anyhow, so the sharing some experience, so that's so for you, that's so that we are going to use substitution, right, to make things simple. And in the process, to select the u equal to something, so look at the secant x and the square root ln of the secant x plus tangent x. And we find that here, so ln bracket secant x plus tangent x, it sounds more complicated or ugly. And normally in the differentiation, so something complicated when we differentiate becomes simpler. So that's why this is a principle to select the u. Yeah, let's try so let u is equal to ln of the secant x plus tangent x. Alright, so guys, let's differentiate and see what are you going to get. Du dx. This is the final hint, and this also integrate that end of the lecture 2. Alright, thank you for the patience to listen to my one man voice. Bye bye.